Hello, good morning, students. Now we can start our subject, the switch gear and protections. The next lectures of the second chapters is constructions and working principle of thermal relay. Now start with the relay. We can some recognize of the previous topic. So in the previous topic we can learn about the fuse. Yes, you can see the fuse, what is the importance of fuse, introductions, which one is there, one is the two metal ending, and between the two metal ending the thin fuse wire is connected, and this one is called the tubes. The tubes is made by the gas or the ceramic tubes. Then after we can study about some terminologies, characteristic of fuse, HRC fuse, how it's working, then operations. They have the two different conditions, abnormal conditions and normal conditions, advantages and disadvantages, the basic difference between the fuse and circuit breakers. Now starting with the relay. So what is the relay? We can study already in the chapter number 1. Basically the relay are the primary protection as well as the switching device in the most of the control process regard of the relay. It means that you can see the figures, the connections of the one is the spring is connected of the end, and another one is connected is armatures. Armature is normally close of the circuit. You can see here the normally close of the second circuit. You can see that the close of the circuit, when the fault is occur, at that time the electromagnetic will be energized, and the connections of the armatures is normally closed connected to the normally open, and the circuit will be open circuited. This one is the basic functions of the relays. Now start with the thermal relay. You can see here first figure, this one, both the figure is represent the thermal relay. Thermal relay mostly commonly use of the overcurrent protections device is the thermal relay. The operating of the thermal relay depends upon the electrothermal effect of the actuating current. It means that you can see here the figures of the what is how it's work the thermal relay. This one is normally open. When you can see the figure, second figures, this one is you can see they normally closed. When the fault will be occurs, the thermally, it means the coil will be energized of the magnet, and this one is a normal conditions of the systems. When the fault is occurs, at that time the elements of the motor side the coil will be a ripple of the armature, and this one is connected with the relay, the circuit will be open. This one is the basic functions of the thermal relay. The symbol of the thermal relay consists of the bimetallic element. The bimetallic element consists of the two elements of the different thermal linear. You can see that together. You can see the figures of the different type of thermal relays. Here the heating coil is kept near to the strip, and heating coil, you can see here the heating coil can be heated directly by passing the activating current. During the heating, when the fault is occur at that time, we can know that the high temperatures and the heating will be started, so that the strip are bent to close the contact, and the spiral constructions is used to save the space and make it more sensitive. This one is the different arrangement of the thermal relay. Now start with the another relay is induction type relay. The induction type relay is called as the magnitude relay. This relay works on the principle of the induction motor or energy meter. Yes, this one is basically work. Know that the we know that the meter of the our housing, this one is the same functions or the same operating principle for the, this one is called the induction relay. Here one disk is connected, putting between the two magnetic fields, and this one is, you can see the figures, the one upper u side will be connected of the operating coil between two these between, and the lower pile will be connected between the disk, between the two magnetic field. The one damping magnetic will be put between them, and this one is rotate, the disk will be rotate using of the torque effect. Now what is the torque equations for to start the disk, it means the rotating the disk. If I consider that phi 1 of the upper side coil, so equations of phi 1 into sine omega t, and the lower side is phi 1, sorry, phi 2 sine omega t plus alpha, it means some displacement. And we know that when the displacement is occur between the two field, at that time the torque will be generated. Now start with the how to rotate the figures. You can see the figures. If I consider that current I1 and I2, and this one is represented by the phi, it means the angle of the phi 1 and phi 2. Now I1 is directly proportional to the d phi 1 by dt, and I2 is directly proportional to the d phi 2 by dt. Now it means we can say that putting the our above equations phi 1 and phi 2 in the equation, so I1 is directly proportional to differentials between the phi 1 sin omega t by dt. It means I1 is directly proportional to the phi 1 into cos omega t, and I2 is cos omega t plus alpha. Now this one we can say that the force is considered between these is phi 1 is proportional to the f1, it means the force 1 is depends on the angle between the second coil, it means the phi 1 2, and similar way the f2 is directly proportional to the phi 2 into I1, so that f is directly total force f is directly proportional to the f2 minus f1. It means that f is directly proportional between the second side of angle minus first side of angle, so that we can putting in the equations f is directly proportional to the values, put the values f2 into I1 minus f1 into I2, and finally we can say that f is directly proportional to the phi 1 phi 2 into sine alpha. So this one, the last equations, f is equal to phi 1 phi 2 into sine alpha, this one is applied to the rotate the disk. So this one is the basic equations of the torque equations. Now induction type relay, how to work, it means the meter of the induction side relay, how to work it. So basically you can see that I1 and I2, it means the phi 1 and phi 2, we can apply the equations of the angle between the two coils. The fault will be occur. Now you can see that the fault will be occur at that time. The coil of the magnet will be energized over the opposite directions of the coils. At that time the torque of the, it means the force at the angle of the phi 1 will be opposite of the phi 2. At that time the torque of the upper side coil and the lower side coil will be different. It means that the force between the two coils is opposite to each other. At that time the disc will be stopped to rotate. This one is the basic functions of the induction type relay. So this one is the functions of the induction type relay. Now what is the basic difference between induction type relay and the thermal relay? So you can see the figures of the thermal relay. This one is the simplest constructions of the relay. When the fault is occur at that time only the armature's movement will be there, but this one is only applicable of the small rating of the motors. Because of here the values or armature rods values will be very thin putting in the system. In the thermal relay you can see that only the two elements, heating coils and the low extension metal strips here, and the different type arrangement will be there to the trip circuit. It means that this one is only generate the trip circuit to given to the open the system, this one. And here the induction type relay. So what is the first meaning, the what is the importance of the induction type relay, how to difference them? The thermal relay, in the thermal relay the fault will be occur. This one is the normally open to the normally closed conditions. There are here the thermal relay have the only the two conditions, open and close. You can see here only two conditions, open and close. And in the induction type relay is applicable for the high rating current. It means that we know that in our houses and the domestic system and the industrial systems the meter, yes, the meter of the rating will be three phase systems as well as the four systems, three phase and the single phase systems. This was the high rating system. At that time this relay will be used. Basic constructions, you can see that upper side coils between the two coils and putting the one disc, and this one is between the two different angles will be applied to rotate the disc. This basic principle we can easily understand of the motors. In the motors the rotor will be rotate when the difference angle will be applied. It means we can say that the 120 different degrees apart from the two each other phases. At that time the motor will be rotated. In similar way the induction type relay is work on these fundamentals. The two upper and the lower side coil and the magnet will be generate the different and opposite each other force. At that time the disc will be rotated, torque will be rotated, different torque. It means this one is, you can see that the angle of the f direct f is equal to the f2 minus f1. At that time disk will be rotate because the torque will be generated between the two magnet, and the equations of F is equal to F1 plus F2. At that time the same torque will be generated, and you can see here the directions of the I1 and I2 is opposite each others, but this current will be same directions. At that time the disk will be stopped and the inductions relay will be operating. So this one is the basic functions of the difference between the induction type relay and the thermal relay. So today we can study about the thermal relay and the induction type relay. Basically these two relay is functions is different and the arrangement will be different. The thermal relay is applied for the normal circuit, it means the inner circuits of the motors, and the induction type relay is used for or applied for the heavy rating systems. So if any query of these chapters or this topic, you can contact me. My number is seen your screen, and if any query about this topic, you can send me the also the send me the message mail. You can see my email id in your screen. Thank you.